This is differentiation using the product rule. In order for us to apply the product rule, we must ensure that the given function has functions which are subjected to multiplication. Let us consider these four examples. In the first example, we have a function y is equal to 2x to the power 3 plus 4x plus 5. So for this function, there are no functions within these functions which are multiplying. So for the first example, we cannot apply the product rule. As for the second example, we have y is equal to x to the power 3, open parenthesis, 2x squared plus 4x, close parenthesis. So here we have this first part and this second part. So we can see that there's multiplication here. So this function is multiplying with this function. So for this example, we can apply the product rule. Since by definition, product means multiplication. So this function has functions which are subjected to multiplication. So the first part of the function is x to the power 3, and the second function is everything in parentheses. So we can show using notations that the first function, let us call it f of x. And the second function, we call it g of x. So f of x multiplied by g of x. Let's consider example 3. We have y is equal to, open parenthesis, x squared minus 3x, close parenthesis, then open parenthesis 2x to the power 3 minus 4, close parenthesis. We identify two functions. This is the first function, and this is the second function. On the middle, there's multiplication. This function has two functions which are subjected to multiplication. Therefore, the product rule can be applied for this function. As for the fourth example, we have y is equal to 4x squared minus 2 over 5x plus 7. We have no functions which are subjected to multiplication. This 4x squared minus 2 divided by 5x plus 7. This is division of two functions, so the product rule cannot work. Now, before we look at the actual differentiation using the product rule, we shall do a quick recap on the use of the power rule. So for the first example, we are going to apply the power rule to find the derivative of this function. So we have y is equal to 2x to the power 3 plus 4x plus 5. To find the derivative of this function, we begin with the notation which we use in differentiation. We can choose from a variety of notations which we use in differentiation, whether Lagrange notation or Euler's notation, which is also known as the function notation, or Leibniz notation. Let us use Leibniz notation. So, the derivative of this function will be given by dy dx. So this is the notation which shows that we are now differentiating. So dy dx is equal to, so to differentiate using the power rule, just look at this power and the coefficient. So we multiply 3 times 2, we get 6. Then drop this x, we have x. Then reduce the power by 1, 3 minus 1, we get 2, plus the power on x is 1. We multiply 1 times 4, we get 4. And reduce this power by 1. So we have 1 minus 1, we get 0. So this will be x to the power 0. Lastly, this 5 doesn't have an x. It is known as the constant. The derivative of any constant is equal to 0. So the derivative of 5 should be 0. So the answer should be 6x squared plus 4, then x to the power 0 is 1. So this changes into 1, but 1 times 4 will be 4, plus 0. So 4 plus 0 will be 4. So this is the derivative of this function. Let us look at the second example. So for the second example, we have the function y is equal to x to the power 3, open parenthesis, 2x squared plus 4x, close parenthesis. So for this function, in order for us to differentiate, we firstly introduce the notation to show that we are actually differentiating. So since this one has two functions, there's this first function and the second function. To differentiate this function, we can identify the two functions which are in this function. So the first function here, x to the power 3, we can call it u. Then the second function, we call it v, like that. So it means that our function is y is equal to u multiplied by v, which can be simply written as y is equal to uv, like that. To find the derivative of this function, we follow the simple rule. Dy dx, which is the notation for differentiation, is equal to du dx multiplied by v plus dv dx multiplied by u, like that. So this is the formula which we follow when we are differentiating using the product rule. So the derivative of this function will be given by dy dx, which is equal to du dx times the v function plus dv dx multiplied by the u function. So according to this notation, let us complete the derivative. So we'll begin with du dx. Now, you know from this function that this is our u. Our u is equal to x to the power 3. What is the derivative of this function? So the derivative of this function du with respect to x is equal to 3 times 1, we get 3. We drop the x like that. Reduce this power by 1, we get 2, like that. So this is our du dx. What else do we need? We want to find dv dx. To find dv dx, we write dv over dx is equal to, now our v is this function 2x squared plus 4x. So our v is 2x squared plus 4x, like that. Let us find the derivative of this function. Dv dx, so we multiply 2 times 2, we get 4. We have x, reduce this power by 1, we have 1, plus 1 times 4, we get 4, then x, reduce this power by 1, 1 minus 1, we get a 0. So the final answer should be 4x plus 4. X to the power 0 is 1. 1 times 4 is 4. So this is our dv dx. Now let us find the final answer. So from this notation, we have dy dx is equal to du dx multiplied by the v function plus dv dx multiplied by the u function. We make our substitution, so we have dy over dx is equal to du dx. So our du dx is 3x squared. We have replaced it here. We multiply this by v. What is our v? Our v is just this function. So we replace 2x squared plus 4x, like that, plus we want dv dx. Our dv dx is this function, 4x plus 4. So we have 4x plus 4 multiplied by the u function. What is our u function? Our u function is this one, x to the power 3, this one. So we multiply it by x to the power 3. Let us simplify. 3x squared times 2x squared. So 3 times 2, we have 6. Then x squared times x squared, x to the power 4. Plus 3 times 4, we have 12. And x squared times x, we have x to the power 3. We proceed. This multiplied by that. So this x to the power 3 can be distributed all over. So we have x to the power 3 times 4x. We have 4x to the power 4 plus x to the power 3 times 4. We have 4x to the power 3. At this level, we collect the like terms and simplify. Now we see 6x to the power 4 and 4x to the power 4. These are like terms. When we add these, we should get 10x to the power 4. So 6x to the power 4 plus 4x to the power 4. We have 10x to the power 4. Then we also have these, the like terms, 2x to the power 3 plus 4x to the power 3, which will give us 16x to the power 3, like that. So this is our final answer, dy dx. So that is the derivative of this function, x to the power 3, open parenthesis, 2x squared plus 4x, like that.